your first draw, you could draw a 1, a 5, a 10, or a 20. If you draw first. So think about really like, try to think about like a forest, right? There's a forest and a wood, and you pick a path. If you go down the $1 path, you can't go back. Now you're here. What could happen next? What could you draw next? 5, 10, or 20. If you drew a 5 instead, then what could you do?
1, 10, 20.
If you drew a 10 first,
1, 5.
or if you drew a 20 first. Does that make sense? Everybody on board? Okay, good deal. Sample space would be a 1, 5, a 1, 10, a 1, then a 20, maybe a 5, then a 1, 5, then a 10, 5, then a 20, 10, then a 1, 10, then a 5, 10, then a 20, and 20, then a 1, 20, then a 5, and 20, then a 10. Yes? Oh. Nope.
Oh, sorry.
Okay. No worries. All right. Now we're going to talk about, this is the last thing we talked about last class. We'll talk about it again a little bit more. Selena, go ahead and read.
Two events are mutually exclusive events or disjoint events if it is impossible for them to occur simultaneously. Exclusive means separate.
Great. Go ahead and read the first rule. Right here. Probability
Probability
Of?
A or B.
of
Probability of A or B equals probability A plus
A.
probability of A plus probability of B.
Yep, if they're mutually exclusive. Perfect. So if they're mutually exclusive, you just add their probabilities. All right, like we had earlier, you guys had the black lab and the chocolate lab. You can't be both at the same time. They're mutually exclusive. So just to reiterate, the best way to describe mutually exclusive is to describe what's not mutually exclusive. If you can be both, then you are not mutually exclusive. Mutually exclusive is if you cannot be both at the same time. Right? So if you're like, so it's, think about this. Two groups that are exclusive means that they kind of keep themselves separate, and they're mutually exclusive. They keep they keep separate from each other. So you can't be in both groups. Like the, I don't know, the Jets and the, when you're Jets or the, does anyone remember West Side Story? Was it Sharks? I was going to say Sharks, but I'm like, I thought I was getting confused by something. So Jets and the Sharks. So you can't be a Jet and a Shark at the same time, right? Because they're mortal enemies, theoretically. Okay, good. The next one here, Shirley, go ahead and read.
They refer.
No. This one.
Oh, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, which is not mutually exclusive.
Right. So in other words, when there's overlap, when you can be both, then you add the probabilities, but then you subtract the overlap because it's getting double counted. So it's like the stuff we just did earlier with like the male puppies and the yellow labs, right? You add the probabilities, but you have to subtract the overlap. In other words, when they're yellow and male. So this does not mean that you add. This and means you have to be both. You have to be male and yellow, right? You have to be a yellow and male lab. So it's when you are both, whatever it is. Okay. Good. Keep reading. Go ahead.
They refer to the same occurrence, same roll of dice, same person selected, same card. Why does it have to? Hint, consider 3 flips of a coin.
Right. So I flip a coin 3 times. What's the probability that I can't find the probability of heads on one or heads on the second or heads on the third. Or not, it can't go that way. Because what's the probability of heads on the first one? 1 out of 2. Probability of heads on the second one?
1 out of 2.
Heads on the third one?
1 out of 2.
What happens if you add those up? 150%. That's impossible, right? There's not a 150% chance that you can get anything. So so this or has to be just on one flip or one roll. Do you guys see what I'm saying? Okay. All right. Quiz problem number 5 in the homework. First of all, this is wrong. Cross out that, put in 0.63. Otherwise, you can't do it. On a quiz. Question number 5 on a quiz. It's 0.63. Sorry about that. So it may have thrown some of you guys off. Let's take a look at it. Who's ever seen a Venn diagram before? Raise your hand. Okay, so not all of it, not everybody. All right, so this here would be our mushrooms. This here is our pepperonis. So all of this are the mushroom pizzas. All of these are the pepperoni pizzas. This is the mushroom and pepperoni pizzas. Good? This section over here, this little kind of crescent half moon, or kind of crescent-ish thing, this is mushrooms only, no pepperoni. And this sort of reverse crescent thing over here is pepperoni only, no mushroom. In theory, there's a larger group out here. So in theory, this would have 4 sections. The mushrooms only, mushrooms and pepperoni, pepperoni only, and then this would be over here would be the group that doesn't like pepper either. No mushrooms, no pepperoni. Good. You guys see what I'm saying? All right. We're not going to worry about that for now. We're just going to focus on these parts here. And this section here, the mushroom or pepperoni that I'm outlining right now, this is the people who are either mushroom or pepperoni or both. There are 63% of them. That 45% is wrong. What percent are mushroom folks? Mushroom only. 38%? What percent are mushroom and pepperoni? We don't know. Okay, how about pepperoni? Only. 16%. Do you guys see where it says only pepperoni? That means that's this part right here. That's this little half kind of crescent moon-ish thing. Or cookie with a bite out of it. Think of it like that. That's 16%. The only mushroom, that's this part over here. So these 3 things added together has to give me my 63%. Everybody on board with that? The folks out here who don't like mushrooms or pepperoni, that's the complement. That'd be 37%. Right, 63%, 100% minus 63% would be 37% that are like, I don't want mushrooms or pepperoni. They have none of that. Okay, we're not worried about that. We're just worried about this 63%. So here we know that this plus that has to equal 63%. Do you guys want a minute to find it on your own? Take a minute and try to find that on your own. All right, so how do I solve this? The first step is to combine like terms. What are my like terms? Oh, actually, first what I should probably do is maybe I'll draw a, we call like a line down the middle where the equal sign is, so you keep the 2 sides separate. Okay, so now what's the first step I'm going to do? Combine like terms. Which one over here are like terms? 38 and 16. Combine those, and you'll get 0.54 plus x. What's the next thing I do? Subtract what?
Subtract 0.54
From both sides. And then I will get 0.09 equals x, so 9%. Okay? All right. So now, just don't solve these, just tell me whether or not they are mutually exclusive or not mutually exclusive. So, first one, male or chocolate. Can you be male and chocolate at the same time? Yes, so then you're not mutually exclusive. Does this make sense? If you can be both at the same time, then you're not mutually exclusive. Because mutually exclusive would mean you can't be both at once. So this is not mutually exclusive. Why don't you guys go ahead and try to figure out the rest of these. I'll give you guys 30 seconds with your neighbors. Go.
Yeah. Yeah. That's mutually exclusive. No, not mutually exclusive. And male or no.
Oh, yeah, the second one. Yeah, same thing.
Have it or
Where? Subdural.
no, I think mutually exclusive has to do with.
So I think I got this.
I think it's black. Black, not yellow or
All right. So it sounds like you guys are done. What's so black or yellow? Can you be both at the same? Can you be both at the same time? No. So they are mutually exclusive. Does that make sense? Female or black? Not mutually exclusive because you can be both at the same time. How about yellow and female? Not mutually exclusive. Again, you can be both at the same time. Good? All right. Oh, so this is the bottom of your page. Fill this in. We're going to talk about or. So or, this is a symbol for or. It's also called the union. I like to think of it, the way I remember or, and the symbol for or, is I think of it as a guy with his arms outstretched. So he's like this. And he's like, I take everybody. Yellow labs, female labs, take you both. It's all good. This is how or, this is the Venn diagram for or. Looks like this. The union, it's everybody. If you're in group A or you're in group B, you're welcome. All of it.
We'll take it all four.
And then there's and. And has a symbol looks like this. It's also known as the intersection. Right, the intersection between two things. I like to think of it as a bow-legged cowboy. Right, so this is my bow-legged cowboy. He has one leg in A and one leg in B. He is in both. You have to be in both of them to be in the intersection, to be in the and. You have to be in this group and in that group. So and means you have to be in both. This is how you draw the Venn diagram for and. It's just this part here. Right, just this little tiny bit. You have to be in both groups. So it's harder, right? It's smaller. If you look at this, it's smaller than A or B. It's less, you have to be in both of them. Over here, or is often bigger than A or B. Right? Because it's this group plus more. Right? So it's a little bit extra.
So the or does include center.
I'm sorry?
So or.
Yeah, it includes the center. Yeah. It's not exclusive or, it's inclusive or. Yeah. So ors are kind of more probable, ands are less probable. And think of it like this. So say you go to the Warriors game, right? You go and you get selected for the halftime show. And they say, hey, you win a Steph Curry jersey if you can stand here and make this free throw. Okay, so it's the first situation. Then say someone else gets picked and they say, you get the jersey if you make the free throw and you make a layup. Which is easier, doing what I did or making the free throw and the layup?
Just a free throw.
Just the free throw is easier because you don't have to do both. The other one, I'd have to pass both tests. I'd have to shoot the free throw and make the layup. Right? You have to pass 2 tests in order to get the jersey. Then say someone else gets selected and they get this option of you can shoot you shoot the free throw, you do the layup, you have to either make the free throw or make the layup. Or which one is that easier or harder than mine? Easier because you get 2 chances to win, right? You can make it this way or you can make it that way. So the or has it the easiest. They get 2 chances to win. The and has it the hardest. They got to do both. So that's less likely, right? That's the least likely. This is the most likely. Right? That's why ors you add. You add in more stuff. It makes it bigger. The and, you multiply things because that makes it tinier. When you multiply things that are smaller than 1, it actually makes them smaller. Like half of a half. Half of a half is a fourth. Right? Take a pizza, you get half. Oh, you get half of that half. Now you only get this fourth. Okay. So why don't you guys work on that problem number 1. And so this is the drawing from an ordinary deck of cards, probably getting a king or a queen or a jack. You guys have the whole deck laid out for you. Do those have overlap or not overlap? They overlap, because you can't be a king and a queen, right? Can't be a king or a jack and a jack at the same time. So take a couple minutes, sort those out.